So in the last lecture we actually discussed the various types of work done in different processes and how to calculate those. Today we will take a simple question. First question is, suppose 2 moles of an ideal gas is expanded. Basically it is first expanded but reversibly from 1 liter to 10 liter at 227 degrees centigrade. This is given actually. So what we have to calculate? First we have to calculate work done. Okay, so first we will do this. So to solve this question, here it is given that it is expanded reversibly. From volume is also given from 1 liter to 10 liter. This is the initial volume, this is the final volume, and 1, that means single temperature is given. That means first identify how to solve this type of question. First identify process. How to identify this? That means if single temperature is given, that means only one temperature is mentioned in the question. That means this process will be simply an isothermal one. That means this is an isothermal process. One temperature, isothermal. Okay. So for work done for an isothermal process, we know is related to by this expression minus 2.303 nRT log of V2 upon V1. This is the simple relation we have to use here. Okay. So first here look into the question. 2 moles, that means what is given? Number of moles is given as 2. N is equal to 2. Temperature, we have to change this into Kelvin scale. So this will be 227 plus 273. When you have to change degree centigrade into Kelvin, always add 273. This is 7, 8, 9, 10. 1, 7, 8, 9, 10, or that means it will be equal to 500 Kelvin. Okay, so temperature will be simply in Kelvin scale 500 Kelvin. Now V1 is also given as 1 liter and V2 is also given, that means 10 liter. What we will do, we will simply insert these values. So W will be equal to, that means the work done, 2.303. In place of N we will insert 2, or we will keep it as such, or whatever may be the question, whether it is in joules per mole per Kelvin or calories, we will see that. First we will keep it as such. as R, that means gas constant. We will multiply it by R into temperature is 500 and log of V2 is 10 upon from here upon 1. So always remember that this log 10 will be also equal to always be equal to 1. Okay, so it will be now easy to solve. It will be equal to, that means it will be equal to, this is twice R, it will be equal to minus 2 3 0 3 into R. Okay, because 5 2s are 10, this will be equal to 1 and this will be equal to this much. So this will be the work done. Okay, but in terms of R, we have calculated this much of work. Now, case first, if it is asked to calculate this work done in calories, then always remember we will put R is equal to almost approximately equal to 2 calorie per mole per Kelvin. So then the work done will be simply equal to, from this equation, W will be simply equal to minus 2303 into, that means multiplied by 2, but this will be in calories. Okay, so this will be equal to 6064. So this will be work done in calories. Case second will be to calculate this in joules. So case second, what we will do in this case, we will put R is equal to, as you all know, that our gas constant is equal to 8.314 joule per mole per Kelvin. Okay, so in this case W will be equal to, we will just put this value into this equation star here. So in place of R, what we will put, 8.314, that means it will be minus 2303 into 8.314 joule. So you will do the multiplication and this will be work done. So this is how, if the question is asked to calculate it in work done in calories and to calculate work done in joules, so this way you can do. And also you have to remember, first you have to identify the process. How you will do that? If single temperature is given, that will be simply isothermal process. Okay, now I will give you the units of pressure. That means here pressure units first, because this will help us in solving the different questions based on this. Also go through the, after watching this, please go through the assignment first and you will see there one or two questions are asked on this also. Always remember here 1 atmosphere, 1 atm or 1 atmosphere is always equal to 760 mm of mercury. Okay, this is also equal to 7, this is also called as torr. You have to remember this. And 1 bar is equal to 10 raised power 5 Newton per meter square, and this can also be written as Newton per meter square. This is given a term Newton per meter square. This is equal to basically Pascal. Okay, so very simple. So you can also write it as 10 raised power 5 Pascal. This is just a unit conversion, and also 1 atmosphere therefore will be equal to, it is equal to 1.013 into 10 raised power 5 Newton per meter square. Or you can say, if I multiply it by the liter, then 1 atmosphere, suppose liter, will be equal to, we know 1 atmosphere is equal to this much. We will first write it as such, 1.013 into 10 raised power 5 Newton per meter square into, liter is converted into cubic meters. So you know 1 liter is equal to 1000 ml or 1000 cubic centimeters, but it will be 10 raised power minus 3 cubic meter. This liter is 1 liter is basically equal to 1000 milliliter, or you can say we take 1 ml approximately equal to 1 cubic centimeter. That means this will be equal to 1000 cubic centimeter also. Now what you have to do, you have to convert this cubic centimeter into meter. We know 1 meter contains 100. 1 meter is equal to 100 centimeter. So when you have to convert it into, then we will multiply it, we will keep it as such, 100 cubic centimeter. Now we need this unit into cubic meters. So what we will do, we will write cubic meter here, but this 1 cubic meter is equal to basically 1000 centimeter, but this will be, okay, this will be whole cube. If you have to convert this into, this will be whole cube, meter divided by 1000 cubic centimeter. Now you can give it back, it will be 1000 cubic centimeter into cubic meter. This will be equal to how much? It will be 10 raised power 3 whole cube. Okay, that means it will be actually 10 raised power 9. Okay, 6. Okay, sorry, 3 2s are 3 3s are 9. No, so I have to write this 100 centimeters. Sorry, here it is 100, because 1 we have taken 1 meter is equal to 100, so it will be 10 raised power 2 cubic centimeter, or I can write multiplied by this 3, so it will be 10 raised power 6 now, 10 raised power 6, but this will be cubic centimeter, 10 raised power 6 cubic centimeter. Now it is very easy. That means this cubic centimeter and cubic centimeter will go, it is 10 raised power 3 divided, it will be equal to 10 raised power minus 3 cubic meter. That is how 1 liter is basically equal to. This is you can take. Simply you have to, suppose if you want to convert this 1 liter into cubic meters, what you have to do, First we know it is basically equal to 1000 ml, or we take 1 ml approximately equal to 1 cubic centimeter. In place of ml we can write cubic centimeter. Okay, now what we are doing, we are just multiplying 1 meter above, also 1 meter below, because 1 meter is basically equal to 100 centimeter. That means this and this will go. So multiplying in numerator or denominator will have no change, so we are just multiplying it, making it cube. That means cubic meter. It will be 10 raised power 2 whole cube, that means 10 raised power 6, and it will be simply cubic. This cubic centimeter and cubic centimeter will go, and you will get this. Okay, so what I was telling you, that how this 1 liter basically is equal to 10 raised power minus 3 cubic meter. So this comes out to be this is plus 5, this is minus 3, it will be 10 raised power 2. When you take this decimal to this place, it will be 101.3 Newton meter. Okay, because this is cubic meter and cubic meter, and this will go. Okay, that is why it is Newton meter now. Okay, this Newton meter is basically also called as joule. So remember, when you have to convert 1 atmosphere liter into joule, what you will simply multiply 101.3. Okay, so that means we have come to the point that this 1 atmosphere liter is basically how much? 101.3 joules. This much you have to. Suppose you have 10 atmosphere liters. Now you want to convert those into joules. What you will do? You will simply multiply 10 atmosphere liters by this much, and you will get simply joules, because 1 atmosphere liter is equal to this much. Okay, this is how a question is asked on this, and that means you have to first remember these units. Always also remember, for questions we approximately, if there are MCQs are generally asked, MCQs multiple choice questions, we generally take this 1 atmosphere liter approximately equal to 1 bar for solving the MCQs. Okay, now going to the question number 2. Question 2 we will take, that means suppose question number 2, 2 moles of an ideal gas expanded from 1 liter to 10 liter. Suppose this is also 10 liter, we'll make it simple, 10 liter. Okay, at 227 degrees centigrade against 2 atmospheric constant external pressure. This is given, external pressure. That means wherever it is mentioned that it is against the constant external pressure, one point should come into your mind, that it is an irreversible process. Irreversible by just looking at that constant external pressure is given. And you know, if only one temperature is given, that means isothermal. Okay, now we know work done for an isothermal irreversible process. We have found this is first an irreversible one and also isothermal, so work done will be equal to minus P delta V. Okay, so minus P, we can write it external. Okay, it is V2 minus V1. So how much external pressure is given? That is here 2 atm. Okay, so we will write minus 2 atm, atmosphere, 2 atmospheres, volume, final volume is 10 liter minus 1 liter. So it will be how much? This will be 10 minus 1, it will be 9. So 9 into 2, it will be minus 18, but atmosphere liters. But what we want this work done in joules. Work done is never asked in atmosphere liters, because this is asked in kilojoules or joules. So what we will do, we know from conversion factor, what we learned, that we have to simply multiply what? 101.3 joules to get this in. Okay, this in work done in joules. Also remember, when what calorie is basically equal to how many joules? 4.184 joules. Mechanical equivalent of heat. You know this concept from the previous classes, but if you don't remember, just remember now. When calorie is equal to how many joules? 4.184. So this is how the different types of questions are solved. Okay. Now one more point you have to remember. So we will write work. First we will write statements, then we will take exam. Work for clockwise, okay, clockwise cycle is negative. I will show you what I meant by this. Work for anti-clockwise cycle is equal to positive. So suppose a graph is, this is generally, this has been asked also in 2019, 18 CSIR net. Okay, these type of questions. Okay, this is pressure, volume. Suppose this is the graph, this type of graph is given here. So always remember, you can calculate work done, that means area under the curve, but whether that is negative or positive, it will be shown by the sign, direction. Suppose if now this is clockwise, consider the clock. Suppose this is clock, it will always go in the right direction, that means to your right, so this will be clockwise. So for this, work done will be, work done, if I simply have to write the sign, work done will be negative, that means for clockwise, because this is direction is given. And one more, if similar kind of this figure is given, and but arrow is showing towards the left, that means simply anti-clockwise direction. So for this case, work will be positive. Now you will see this statement again. Work for clockwise cycle will be negative, and work for anti-clockwise cycle will be positive. So this should be clear from these two figures. Okay. Now I will give a simple question based on this. question is, suppose a figure is given here. Okay, it is arrow is also clockwise. So if I first join the two extremes here, this also to the y-axis. Suppose this is this direction pressure, this is pressure axis, this is volume axis. Here this is given as suppose 6 liters volume this way. Here this is 2 liters. That means initial volume, final volume. This is 5 atm and this is 1 atm. Okay. Now we know work done is basically the area under this curve. Okay. So first we will find the work done, magnitude of work, without knowing whether this is positive work or negative work. It will be simply given for this case. It will be pi r square. Okay, area of this circle, it will be pi r square. But we don't know radius. If you look closely, it will be 6 minus 2. How much? 4. Or 5 minus 1. It will be how much? 4. So diameter is 4. So radius will be simply equal to 2 then. So if we put the values here, pi 2 whole square, this will be 4 pi. But this is only the magnitude. Now arrow is also given. So we know for a clockwise direction, clockwise cycle, it will be having the negative sign. That means minus 4 pi. This minus sign basically shows who is doing basically the work. Okay. Done by the gas or done by the system, or work done on the gas or work done by the system. Okay. So this will be here negative. Now one more, this type of question we can solve here. Suppose this type of graph is given or figure is given. Suppose this is pressure axis, this is volume axis. Okay, so this volume is equal to 2L, this much 7L, this is A, this is B, suppose C and D. Okay, we can solve this question by one more means. Simply we know one method just by finding the area under this curve and whether this is clockwise or anti-clockwise. So this time it is clockwise, so we know it will be negative work. But one more thing is here, that we can work is negative by just looking at the arrows. We can just calculate the total work done. That means W total, if we have to calculate for this case, suppose this is W1, this is W1, this is W2, this is W3, and this is W4. Okay, Now that means this total work will be the sum of these four types of workers. Okay, W2, W3, W4. Okay. Now if you look into W1, what is remaining constant? If you go from point A to point B, look at here, volume is changing but pressure is remaining constant. So this is an isobaric process. So work done will be minus P delta. So this will be equal to how much pressure is here given? That is 5, because this is constant. Only you have to consider A to B. You are going from A to B, this point. Pressure is not changing but volume is changing. Okay, that then we can write here minus 5, the V2 is 7 liter minus 2 liters. So this will be how much? Minus 7 minus 2, it will be 5. 5 into 5, it will be 25. Okay, 25 but in atmosphere liters. Okay, you know how to change this atmosphere liter into joules. Just we will multiply it 101.3. Okay, we will do that at the last. W2. Now consider this. Here W2 is if you go from B to C. Okay, what is remaining constant? Volume is constant. So work done will be simply equal to, this is isochoric process, work done will be 0. Okay, now going to the W3, again work done will be given by, what is this? This is isobaric process, so it will be minus P del. Now here you have to remember pressure is here 1 atm, because at the C point and D point, this is initial and final pressure is 1, so we will write it minus 1, but atmosphere 1 atm. Okay, now here the initial volume is now this 7 liter and it is going to 2 liter. This is the important point you have to remember, that you initially start from C to D. So what will be the initial? Initial will be 7 and final will be 2. So we will write V2 minus V final, that means 2 minus 7 liters. So this will be how much? This will be 2 minus 5 minus 5 minus minus will be plus, so it will be plus 5 but atmosphere liter. Okay, this is W3. Now what about W4? W4 is again, this is isochoric process. Okay, volume is remaining the same, pressure changing, volume remaining same, so work done 4 will be 0. So now you can calculate the total work done. That means total work done is equal to W1, that means minus 25, plus W2 is 0, W3 is how much? Plus 5, so we will write plus 5, and W4 is how much? 0, so it will be atmosphere liter. So it will be how much? Plus minus, it will be minus 20 atmosphere liter. Now you can simply change this into what? Joules. So simply we will multiply it by 20 into 101.3 joule. Okay, so this will be the total work. Okay, so the easy method I have told you that you will just find the area under the curve. Area, what is the area? This is 5 minus 1 is 4, 7 minus 2 is 5. It will be 4 into 5, it will be 20, but positive or negative, it will be negative. So this way you can directly find, but this is the proper way of finding, applying those equations what we have derived in the lecture second, that were done in different processes. So here please go through this figure 2-3 times and see what is point A, what is remaining constant from point A to point B, and what is changing, okay, and what will be the work done. Then it will be easy for you people. I hope you understood this lecture. If you have any question, you can ask, then I will be happy to answer those. Okay, thank you.